Hello, everybody. Welcome to Variety Hour. I am Alex Rude from the WILDLABS team, and I'm going to be your host for this month's July Variety Hour. We have some great speakers lined up today, which include some speed talks from Kevin Darras, Vanessa Prema, and Timothy Keitt, and a long talk from Roxanne, Beltran, and Allison, Payne. So with that being said, we will kick things off. I'm going to hand it over to Kevin, who's going to introduce Worldwide Soundscapes, which is the first global passive acoustic monitoring metadata database and network. And he is way ahead of me sharing his screen, which is great.
Thank you very much, Alex, for the introduction. And I'm pleased to give a 7-minute talk today about the Worldwide Soundscapes project. And some of it is going to be about the synthesis that we recently published, together with some co-leads that are listed here and a very long list of authors that I unfortunately cannot put on this page. So today we're broadly interested, yes, it goes to the next slide, in the question of what is the planet made of in terms of sounds. You know that a variety of sound sources exist, and especially our community is interested more specifically in those of biodiversity. And the interesting thing here is that sound is a very fundamental general phenomenon. It's just a mechanical wave that propagates through media, gases or solids. And we like to take advantage of that in our network in the Worldwide Soundscapes project to monitor soniferous biodiversity, so the biodiversity that uses and emits sounds. You can see some examples here of how we like to deploy our recorders in a variety of habitats and ecosystems. So this is to honor the people who wait to great lengths to record these extraordinary sounds in these challenging habitats in the freshwater, marine, and terrestrial realm. And after this illustration, I'd like to tell you more about what the project is actually about. So it first started a bit more than 3 years ago as a database of metadata for passive acoustic monitoring. To date, we have a few hundred contributors that have joined what became a loosely connected network sharing news about science soundscapes on a global scale. And our database comprises almost 300 metadata sets for the terrestrial realm, about 100 for the ocean, and relatively few at the moment for the freshwater and subterranean realms, but more are coming. We are including data sets into this database that respond to the following criteria. This has to be passive monitoring. We're not emitting any sounds. This is really about recording the ambient sound in diverse ecosystems. We are using stationary sensors because otherwise things would be quite complicated. And we distinguish ourselves from citizen science projects by requiring a certain level of replication in space and time. Most of what is in our database, actually all of it, is hosted on this website, whose link you can see here, and I'm going to take you to it. This is hosted on EcoSoundWeb, which is an ecoacoustics online collaborative platform. And you can see here a spatial overview of what we have in the database. And you might be interested as a practitioner, as a PAM practitioner, in what kind of PAM projects exist in your region, what kind of ecosystems have been sampled. You can see here that the different colors correspond to different ecosystems, and you can filter them here and look at what exactly is of interest to you. This is the first use and most important one about the WWSS database. It's like your phone book or an inventory of what has been done in terms of passive acoustic monitoring worldwide in all ecosystems. But we can go in further detail because for every collection or data set that has been compiled here, we can go inside and look at, for instance, what the Australian Antarctic Division has done around Casey Station in those different years. You can see the exact timing and duration of the recordings they made here in the marine realm. And what we were interested in while we worked on our synthesis was to provide an overview of the current state of passive acoustic monitoring sampling on the globe. And so we've done a variety of figures, and this is one of those that is showing how the different sampling sites are distributed in space along the latitudinal and the topographical gradients. We used this to identify some sampling gaps, so regions or geographic gradients that are currently underexplored in acoustic terms. And we also went further by selecting a very small subset of recordings that we systematically analyzed to find out how many sounds are occupying the soundscape that are of natural, of human, and of geophysical origin. And we did this to illustrate what the database's potential is for answering research questions of macroecological, conservation biology, or phenological order, just as a few examples. So if you're interested in this, you can look at the paper that is linked below here. But more importantly, today is about connecting with the WILDLABS community. So this is really a call out for anyone who's interested in participating in the WWSS project. You can simply just use the data. The metadata are archived on Zenodo. I can open that link for you here. You can download all the CSVs. They're described. If they're not accurately described, just let me know. And you can also download the demonstration recordings that we analyzed, those that I mentioned before for answering the ecological questions. And I can just show you a sneak peek of, for instance, what has been done in Australia, in Perth. You can see here in the estuary that some recordings were made. And for instance, this one is an interesting one where we can see mulloway fish calls down here that are composing the biophony of this soundscape, while some anthropophony here from the harbor sounds are found. So this is the level of detail you can get. Some collaborator of mine recently used those sounds for an acoustic exhibit. There's all kinds of things are possible because these recordings are open and Creative Commons licensed. If you're interested in participating in the project more actively, the project is open and will remain open for contributors. Just drop me a line. Here's my email address, and that's my timer that says that I should be finished. What's coming up next is going to be not a synthesis of metadata, but a synthesis based on the recordings themselves that are referenced by the database. So if you're interested in this, just don't hesitate to contact me. Thank you very much for listening. There's no time for questions, but I'm glad I had these 7 minutes.
Thank you so much, Kevin. I have a question for you that I'm going to put in the chat about like standardization of data because I want to ask it and I want you to answer it, but I'm going to put it in the chat. And I'm going to also, but thank you for that great presentation.
Thank you very much.
Awesome. So next up in our speed talk is Vanessa Prema, and she is going to be telling us about a project that is studying buzz vocalizations from Himalayan birds with AI and machine learning. So Vanessa, whenever you are ready to take it away, she's taking it away. It's all you.
Sweet. Great. I'm here to present the bird audio analysis work from Freeman Labs. I'm Vanessa Prema. Thank you, Alex, for the intro. A little bit about me. I am a second-year master's student of computer science at Georgia Tech. I am currently based in San Diego, California. So hello to my fellow San Diegans. I saw a couple of us in the chat. Our research team is part of Dr. Freeman's lab, and they primarily focus on the study of birds in mountain regions. Our research team is within the HAG group at Georgia Tech, the Human Augmented Analytics Group. This program is really cool. It connects master students to interdisciplinary research groups. I've included a few links for anyone who's interested to learn more about the different projects within HAG. Really cool, diverse group. I highly recommend you guys check that out. All right, a little bit about our bird. The Hume's leaf warbler is a small songbird native to the Himalayas. Our focus is to improve the recognition of this bird, specifically the song. And I'll refer to this song as a buzz sound. That's kind of what we refer to in our research, and the call of this bird. These bird vocalizations offer critical insight into the species presence and behavior in the Himalayas. So how is our data being collected? The Freeman team deployed 30 audio moth recorders across the Himalayas in different forested mountain regions, and the devices were strategically placed near known habitats of the Hume's leaf warbler at various elevations. And they're set to record in intervals during the summer months at early hours. So that's when birds are most active in the morning. And the objective here is to build a high quality localized audio data set for this species so that we as developers can have a robust data set. BirdNet is our benchmark. It is an open source tool made by Cornell that takes in audio and outputs bird species predictions. We use this initially to process over 500,000 3-second audio clips. Each clip was labeled with species and confidence scores. But what's important to note here is that BirdNet doesn't give us any vocalization type information. So it'll tell us the species of the birds, but it's not going to tell us if it's a buzz or a call or a song of that specific bird. Still useful for us. It helped us identify the presence and absence of species in the field, estimate the frequency of the Hume's leaf warbler in specific elevations, and explore patterns of our bird with other birds in the area. So where we as computer scientists kind of come in, we put together 2 custom models. The first one being the object detection model and the second one being the audio spectrogram transformer model. And both of these models share the same pre-processing and architectural setup. And this is just to ensure that when we compare them down the line, it's as the baseline is still the same. Our data set is cut into 3-second clips from the 15-minute recordings from the field with a 50% overlap because this buzz sound is usually around 1 to 3 seconds long. We collected data points from varying elevations and converted these to linear scale magnitude spectrograms, as you can see here. We then crop them to 5 to 11 kilohertz frequency range because our buzzes and typically birds sing at a higher frequency. So that kind of cuts out some of the data that we're putting into our models. We manually annotated this data using CVAT with bounding boxes over known buzz sounds and non-buzz regions. A little bit about the specifics of our model. Our object detection model uses YOLO V11 as its object detector. It is pre-trained on ImageNet that's repurposed to detect patterns in spectrograms. It's well suited for our case specifically because YOLO does really well with these compact shark shapes here. Because the buzz looks like that, it is a good tool to use for us. We also use an audio spectrogram transformer model, and we fine-tune this model from AST with ImageNet weights. This is a transformer-based model that interprets spectrograms similarly how vision transformers interpret images. But like I said earlier, these are both trained on the same curated data set that's focusing primarily on this buzz sound versus all other vocalization detection. In summary, BirdNet supports a broad ecological analysis offering large-scale insights into species presence, but the OD and AST models that we put together kind of give us a fine-grained detection of buzz vocalizations. Down the line, a comparative evaluation across methods will inform us of the best performing approach for this future deployment. And what's next for us is we're just focusing on one sound, one vocalization of one bird. We hope that we can use our tool to identify other vocalizations of the Hume's leaf warbler and eventually across multiple bird species. Acknowledgements, just want to do a big thank you to the HAG group and my fellow researchers, Eric, Andre, and Tom, as well as Freeman Lab and our computational advisors, Marco and Yasha. They're able to help us with a lot of our research initiatives. And thank you for listening.
Thank you so much.
Great.
I have a question that is sort of tangentially related to everything you just talked about because I was on the project website page earlier today. Actually, there's a question from someone in the community that just came in. So I'll actually read that one because it's more important. So Nathan is asking if you are collecting data from SD cards manually or if you have anyone else or if there's anybody else that has managed to transmit audio moth data over radio or satellite communications with limitations on speed of the serial interface. I think if you read that question, you might have a better.
I can't speak to the actual data collection. My understanding it's probably from this SD because we have someone actually out there in the Himalayas right now collecting, and they upload it to a website that we collect the data from. So I don't think it's over radio. My understanding it's physical, but I can get back to you with a proper answer for that.
Amazing, thank you. I am still going to ask my question because I'm curious and we have a few seconds left. On the project website, it said that one of the goals of this was to potentially start hypothesizing why these birds do this buzzing vocalization as like a behavioral
Correct.
like assessment. Are there any either insights coming from that, or do you have any fun guesses or anything that's been coming to light?
I'm thinking it has something to do with the breeding because these sounds only come from males. So it's almost like we're wondering if there's some sort of correlation there. If like the frequency or the length of the buzzes correlates to any sort of breeding patterns with them. I think that's what they're kind of hoping to look for, but we can't really hypothesize until we finish looking at all the data. But that's what I think might be
Well, we'll
a part
find
of
out
this.
hopefully soon. Amazing. Well, thank you so much, Vanessa. And we are going to hand it over to our last speed talk of the day, which is from Timothy Keitt. And he is going to be sharing a little bit about BioSense, which is a low-cost and fully programmable automated sensing platform. Whenever you're ready, Tim.
Thanks. Yeah. Thanks for the invitation. So this work we've been doing for a number of years, and it was motivated by, as you all are really familiar with, the rapid pace of change in the environment and the limitations and how much we can spend, in the field monitoring and collecting data. So this is to augment field studies. And so we proposed kind of a model. You could read a little bit more about this in the science paper, but the idea that we would build devices that are, connected, have communications, potentially can inform in near real time, have intelligence embedded at different levels throughout the kind of setup, potentially, hopefully self-sufficient with, low duty cycles where we don't have to go out constantly to retrieve data, but that they can operate somewhat self-sufficiently and maybe adaptive. This is a sort of high and mighty idea, but we'd like the idea if we could have these devices actually learn to respond to novel inputs over time. And so that's kind of more in the AI research. So we put together this platform, and here's an example. It's basically a Raspberry Pi in a box. And we've been focusing a lot on sound recording because it has a large footprint. You can integrate a lot about the environment in an area by doing sound, whereas, for example, camera trapping and so on has a very narrow focus in the environment, although we're interested in moving into those kinds of things. So we also do microenvironment at the same time. We really want to understand better the relationships between activity and those sorts of microenvironmental things. Here are some of the kinds of sensors that we've been putting on them, and we're interested in expanding that. Deployments. This started out with funding through our field station network in Texas. So we've been deploying there, and we're going to complete this in this year, having these up running on all of our 7 sites within the hill country. Locally, we've done some work with golden cheek warbler in the Balcones Canyonlands, down in South Texas, a popular birding spot where I take students, and so we have some device there. And then we have 4 now out in Tipitini Biodiversity Station in Ecuador. This is me a few weeks ago programming one of the devices 45 meters up in the canopy tower. So we've been recording there a bunch of places. And so it's this is probably unnecessary level of detail, but anyway, we've run into a lot of interesting things as biologists starting to work with all of this electronics. Power supplies are really important, and it's easy to underestimate. Reliable connectivity in the field is hard. I've spent a lot of time working on virtual private networks and things like that, but it's still quite difficult to maintain consistent connectivity, and so there is some intervention needed. Configuration is, vastly easier if you can tap into the box from your laptop. So we've been making access points. The AI, we do BirdNet like everybody, and AI is very complicated and it gives you a lot of very solid false positives. And we're really working hard onto better ways in which to deal with that kind of data to make good statistical inference. It's been a wonderful project for students involvement, which this is a pair of Ecuadorian students that we were working with this past few weeks. learning about the platform, but we've had a lot of computer science and engineering students come into our lab, and that's been really fun. And the other thing is, don't always do it yourself. We've given out a recipe. You can look at the Hardware X paper, which is pretty basic. We've gone way beyond that, but there are, computer and electrical engineers really do know what they're doing. So we're working with like the robotics labs on campus and stuff like that now to do custom PCBs and things like that. So there's a lot of that you can do yourself, but getting the expertise and interdisciplinary work going is great. I've written a whole software system for this, and that'll become out open source pretty soon. And so it's a client server setup. I can't go into all of this, but one of the things we do is we record continuously rather than in small bytes, and then we thin the data later intelligently using AI tools so that we can go for potentially years. And that's my stop. Have these accumulate data for a very long period of time. So anyway, a bunch of people in the lab did great work on this, and we've had some various kinds of funding, and I'd be happy to take any questions. Thanks.
Thank you so much. I have a question. So it seems like this is pretty a pretty customizable tool. Are there any, I guess, are people already using it in the field? And if so, has there been any applications or customizations that you've been surprised by or excited about to see in the future?
Well, so far it's been just us in a sense. I mean, I think other people are doing sort of pie-based, things like this as well as our group. So there are a lot of interesting applications out there. Amongst us, I think we've been doing some soil temperature and moisture probes on these devices, and I find that really interesting because we had working with another group that does automated plant and ecosystem exchange, so more carbon and water balance kinds of work. And we worked with one of their grad students, and they showed us how we could integrate their kinds of, they do sap flow monitoring and a bunch of things. And so we're very keen on the idea that the ecosystem properties are very relevant to our understanding of, say, wildlife activity, biodiversity, and so on.
Amazing. Well, thank you so much. And I definitely encourage you, if there are any other issues or all those issues and challenges that you had on the previous slide about AI and hardware integration and whatnot. I feel like you're in good company, and definitely encourage you and anybody else who's having issues or facing challenges in their research to post about it on WildLabs. It's a great place to commiserate and find solutions and connect with other folks. But thank you so much, Tim. That wraps up our speed talk section of today's Variety Hour, which means it is time for our ad break. During the WildLabs Variety Hour ad break, we walk through some updates and news and important information from the WildLabs team to share with our community, as well as running a fun quiz before we jump into our long talk. So, welcome to ad break. To start us off, I'm going to pass it over to Talia to share a little bit about our newly launched annual report.
Thank you, Alex. Hi, everyone. Great to see everyone here today. Just a quick announcement to share that our 2023-2024 annual report is now out. We're really excited to share this with all of you. It captures 2 years of really transformative growth and evolution of our programs and our community, including our community passing the mark of 12,000 members in 135 countries across the world, which is pretty amazing, considering we had, I think, 300 members when we were launched by the end of the first year of launch in 2015. We have also launched, as probably many of you know, a couple of new funding opportunities, which we'll talk about in a second. We've made really massive improvements to our platform, and then also been kind of sharing more and more influential research that's now informing policy and conservation tech agendas and efforts kind of all over the world. It's been a labor of love, and it is kind of a nice summary of just our evolution and progress over the last couple of years, but also where we're thinking about where we're heading now. So we would love it if you would go have a read, share it, let us know what you think. Thanks so much.
Thank you. Hopefully someone in the WildLabs team can drop a link to that in the chat. But yeah, big labor of love. That's the best way to phrase it from our team, and we're really excited about it. Next up, I'm going to hand it over to Adrian to ask everybody for a favor from the WildLabs team.
Yes, thank you, Alex. Hi, everyone. Can you hear me okay?
Yes.
Cool. So yeah, it's more than a favor. I think it's we are or maybe you don't. We recently made some improvement to our platform, and now we are capable of managing data more. I would say better than we were in the past, and for us, data is very important for our annual research, as Talia and Vanessa are leading, and one key component of the data that we can find on this platform is the origin of the member, the nationality or the country where you are based or where you are from. And for us, this data is very important because it helps to see the gap, right? You straightforward see where conservation tech, or at least where we don't have members, and therefore where we believe that conservation tech is not well represented. And so our favor, or my demand today is, please, if you have a WildLabs profile, make sure that you have filled the country in your settings, and here on the left of the screen you can see how to do so. Thank you very much.
Thank you. Yeah, please go do that. I actually didn't have mine done until like 3 days ago, so it's never too late, and I've been working here for a year and a half. Okay, awesome. Next, I'm going to pass it to Henry to talk about the Boring Fund.
Thank you very much, Alex. Hi, everyone. I'm excited to inform you again, just in case you missed it on the last Variety Hour, that the Boring Fund, a grant opportunity run by WildLabs, is open for applications right now. So the Boring Fund is a unique opportunity, which we're really, really proud of. It's designed to support the essential behind-the-scenes work in conservation tech, so things like documentation, maintenance, training materials, all the sort of more unglamorous but critical stuff that helps keep tools and projects running. So we have $80,000 in total available, but each project can apply for a maximum amount of $12,500. And yeah, we're looking for ideas that don't usually get funded, but really should. So if that sounds like your work, then please do apply. And I'm going to pop a link down in the chat.
Amazing.
And
Thank you so much, Henry.
Thank you.
Thank you so much. We are super excited to be having this for the second time around. Please apply. All right. And I think this is our last announcement from today is from Vanessa.
Hi, thank you, Alex. Hi, everyone. Great to see you all. So we are calling for volunteers who would like to join myself and Juan Ulloa from the Humboldt Institute in Colombia as new co-leaders for our Latin American community in WildLabs. So now, if you excuse me, I'll make this announcement in Spanish. Hola a todos, estamos buscando personas que quieran sumarse como co-líderes del grupo de la comunidad latinoamericana en WildLabs. El año pasado creamos este grupo junto con Juan Ulloa del Instituto de Humboldt en Colombia y lo venimos co-liderando. Vamos a continuar nosotros en este rol, pero quisiéramos sumar 1 o 2 personas que quieran ayudarnos a hacer crecer la comunidad. Y especialmente si hay alguien que hable portugués, sería genial para poder fortalecer el uso de esta lengua en el grupo. Este es un rol voluntario que requiere solo unas pocas horas al mes. Se trata de compartir recursos en el grupo, ayudar a conectar personas cuando haga falta y organizar algún evento que sea de interés. Así que si alguien tiene tiempo y ganas, nos puede escribir a Alex o a mí. Ahora les dejamos los mails en el chat. Y bueno, si quieren consultarnos más detalle, los pueden hacer. Muchas gracias.
Thank you. Thank you so much. Yeah, I'm not totally sure everything Vani just said, but reach out to her or I if you are interested in joining the Latin American group. I need to brush up on my Spanish. And now it is time for this month's quiz, which is on acoustic monitoring, all things acoustics. we might face a technical difficulty towards the end of the quiz because I haven't quite worked out the kinks of something, but we're gonna roll with it. I might need an assistant, but I also might not. Okay, question 1. What is the difference between infrasonic and ultrasonic sounds? Is it, oh, I wrote a lot for this answer. Is it that infrasonic sounds are less than 20 hertz and ultrasonic sounds are more than 20,000 hertz? Is it that infrasonic sounds are produced in the troposphere and ultrasonic sounds are produced in the stratosphere? Or is it that infrasonic sounds are made by animals that can perceive infrared radiation? Everyone's saying A, but maybe it's not A. It is A. Tricked you guys. Henry wants to believe that it's not A, but it is A. Good job to everybody who guessed A. Second question. What is color density representative of on a spectrogram? Is it rarity, amplitude, frequency, or proximity? Everyone's saying, not everyone, okay, a lot of people, the answers are coming in hot. But Kevin is saying and D in a sense. Okay, the philosophical question. But Henry's saying C. He's being a contrarian. Andrew is asking if I can read it again. Yes, the question is, what is color density representative of on a spectrogram? But it seems like there's a consensus, and the consensus is B. And here is a larger image that represents the amplitude I'm not a bioacoustician. I don't know. But yes. Amplitude is the answer, which is how loud something is. I do know that. Next question. When recording, the sampling rate, which is measured in kilohertz, should be how much higher or lower than the frequency that you want to record? Is it 3 times higher, 1.5 times lower, 2 times higher, or 3 times lower? People are saying C. People are saying C. People are saying C. And that's right. The answer is C. But Kevin is at it again, saying it's actually C plus a little more. So remember when I said that there weren't any errors in this month's quiz? I was lying. Okay, Carly, 2 times is the minimum, but more is advised. I learned something new. And that's what the quiz is all about, for me to learn. Okay. What causes a songbird vocalization to sound more pure or whistly, whereas something like a hawk might sound more harsh or screechy? Is it harmonic differences, vocal cord length, mouth cavity size, or one is just scarier by nature? Henry says B. Adrian says D. Carly's saying A. We're getting a mix of things. Who can know? But there is a slight trend towards A. Nathan isn't sure on this one. And the answer is A. And in case you didn't know, which I didn't know until I made this quiz, that harmonics are sound waves whose frequencies are whole number multiples of the fundamental frequency. But also D is probably true as well. I think this is the final question. And here's where we might run into technical difficulties. Oh God, I might have just revealed the answer. This is, whatever. Okay, I'm gonna play a sound. Let me know if you can hear this. Can you hear this? Sorry that I might have botched this. Okay, Adrian, I know, that's why I said that I might have ruined it. Ay. Okay, well, is it a common nightingale? Is it a sperm whale? Is it a cheetah? Or is it a convict cichlid? I'm bringing cichlid back into the Variety Hour quiz. It is a cheetah, and I'm so sorry. But I warned you all that it would happen. And in case you didn't know, that sound is called a chirrup. Yeah, I'll do better next time on that aspect of things. And that concludes the Variety Hour ad break and quiz. Like I said, something always goes wrong, whether it's an incorrect answer or something else. That's the magic of the quiz. Thank you for applauding, Talia. And with that, we are going to move on to our last talk of today, which is our long talk from Roxanne, Beltran, and Allison Payne, who are going to be talking about some novel acoustic recorders that can listen in on the ocean soundscape.
Awesome. Thank you so much. Well, we can't see you, but I'm going to assume you're still there unless you tell us otherwise. We are super excited to share a research project that we've been working on interspecific eavesdropping in the deep sea. So my name is Roxanne Beltran. I'm an assistant professor at the University of California, Santa Cruz.
I'm Allison Payne. I'm Roxanne's graduate student.
And yeah, we work on large marine vertebrates and marine ecology. We're kind of biologists by training, but more and more we're realizing that as we think about how animals move in the landscape and what they're actually doing, we really need to understand what they're experiencing and what they're perceiving. And so we've sort of both moved more recently into the acoustic space to try to get a better sense for what exactly the animals are doing. So we're really, really excited to talk to you about some of the work that we've been working on. So the deep ocean is characterized by darkness, by cold, and by crushing pressure. And for the animals with the physiology and morphology to sort of access that mesopelagic zone, it's also a treasure trove of prey, like these lanternfishes that you can see here. So the marine mammals that we study, including elephant seals, make a living by finding these deep prey resources. They travel hundreds of miles offshore and thousands of meters beneath the ocean surface to eat these fish and also squid, and they spend most of their lives in the darkness of that twilight zone. But if seals are traveling hundreds of miles just to feed in the dark, one of the major questions that we have is how are they actually finding the prey? So we know from research by colleagues that at a really fine scale, they use their whiskers. The video that you're seeing here is actually a very small video camera glued to the cheek of a seal. So you're seeing the seal's whiskers sort of move through the water at hundreds of meters below the ocean surface as the seal tries to find fish, the wakes of the fish that are swimming in front of the seal. So we know they use whiskers at a really fine scale, and they also clearly use some kind of memory to return to the areas that they've been before. We also know that they have really good hearing, as good as toothed whales into the high frequency range. But like the other marine mammals that use this mesopelagic zone, so about 200 to 1,000 meters beneath the ocean surface, the seals can't echolocate. So if echolocation is a sensory adaptation that allows toothed whales and dolphins to more easily find prey in the vast open ocean by basically emitting high frequency clicks and then listening for the return echoes to figure out the distance and size and shape of objects, including their prey, we wondered, is it possible that elephant seals might be finding their prey by basically eavesdropping on the echolocation sounds made by odontocetes in the open ocean? Basically, are they stealing information about where the prey are by leveraging a sensory system that they don't actually have? And it turns out that eavesdropping is actually really common in wild animals, both within and across species. So, for example, dik-dik listen for the alarm calls of the go-away bird and basically increase their vigilance when they hear that bird. And eavesdropping can also be really useful for foraging contexts. So sika deer are basically drawn toward the call of snow monkeys because the monkeys eat fruit and the deer can easily forage on that fruit that drops to the ground. But to our knowledge, we don't know if eavesdropping occurs or facilitates foraging success in the deep sea. One tool, of course, that can give us clues about what's going on in terms of acoustic interactions in the open ocean is passive acoustic monitoring, where microphones can measure all sorts of things we've already heard about today, including sound produced by animals, sound produced by the earth, like earthquakes and rain and wind, and also sound produced by humans, like seismic surveys and shipping and development. And these acoustic monitors can be used across ecosystems, so across habitats on land and at sea and in aquatic environments, but they do pose some trade-offs, of course, in terms of how they're actually used. So in terms of their temporal spatial resolutions and in terms of sort of the coarseness of those data. So for example, fixed acoustic monitors can record for really long periods of time, but only in a single place. Whereas acoustic monitors that are on moving platforms like sail drones or ships can record across locations, but usually only for limited durations of time. And so that sort of brings us to our study system. We know that instruments that are small and can be attached to animals can help us not only understand what individuals are doing, but also understand their environments. And these instruments attached to birds and reptiles and mammals and all sorts of things are being used at scales that we've never seen before. So right now, tens of thousands of animals across the globe are instrumented with these biologgers. We can watch them move and we can see what they're doing and we can understand their habitats. And so we basically wanted to leverage this ability to make instruments, to carefully attach them to animals to collect data about the environment, this time using Acoustic. So I'm going to pass it to Allison, who's going to talk about the project.
Yeah, so if our goal was to figure out if seals are eavesdropping on whales, then we wanted to kind of make some hypotheses about what that would actually look like in our biologging data. So we had 3 data streams on the elephant seal, and so we made 3 different hypotheses about kind of what each would look like if the seals are following those whales. So at the broadest scale using GPS, we would expect over a 12 or 24-hour scale that when a seal heard echolocation, she would switch maybe from transit to searching behavior, for example. At a more hourly scale, we can use the depth recorder to look at the shape of the dive, and that can tell us the behavior that the seal is doing, whether it's transiting or foraging or sleeping or some other things. So in this case, we would expect that if she hears echolocation, she should switch to foraging behavior, and we would see that in the dive record. And then finally, at the smallest scale, we can use the recordings themselves. And this is where that kind of amplitude and proximity gets in. We can use that fact to look at the received level of sound on the hydrophone. So if seals are going towards whales or if they're coming closer to each other, then we should see an increase in the received level of sound on that hydrophone. So that's what we're kind of looking for across all of these different scales. And elephant seals are a really excellent system to look for this evidence of eavesdropping because they have this extremely impressive 10,000 kilometer round trip, foraging all the way into the open ocean, and then they come straight back to the beach in California, about 20 minutes up the road from our lab where we can find and handle them. So we have extensive practices and protocols in place to sedate the seals, instrument them, then they go off on their foraging trip, come straight back to the same beach usually, and then we can remove the instruments and do the whole process again. And so this allows us to reliably recover the data. And because the seals are quite large, around 500 kilograms, the instruments don't usually, they don't have big impacts on the seals or affect their natural behavior. And in fact, a lot of instruments are first tested on elephant seals because they're very robust animals. And we have a variety of sensors that we can use. I mentioned the GPS tag that can measure latitude and longitude, but also the depth trigger, which can tell us how deep they dive and the shape of those dives. And like I said, that can tell us if they're transiting, resting, or foraging. And the last piece is our passive acoustic recorder, which can record the soundscape of the deep ocean on foraging trips, including high frequency sounds like echolocation. So from that tag engineering perspective, the thing that was really missing was, as I think Tim mentioned earlier, having battery to last for this really long foraging trip, and something that could also survive the pressure and salt water of the open ocean. So this was a real engineering challenge. So thanks to the Arnold and Mabel Beckman Foundation, we set out on this adventure to build this tag. We partnered with engineers and acoustic experts at Cornell who helped us through a lot of iterations of housing shapes, different battery potting techniques, different configurations of everything to try to avoid air bubbles that could implode under the ocean's extreme pressures. And so it was many, many, many prototypes. I mostly broke things, and that was a very instructive experience, I think. And there were also, all kinds of other challenges, supply shortages during COVID-19. But our first prototype we were able to put out in 2023 on a juvenile seal. We did this kind of translocation of her. So we picked her up from the beach. She was a young seal. We can't do this with the adult seals, but we picked her up from the beach north of Monterey Bay, drove her on Highway 1 down to Monterey, and then set her out in the evening, and over the course of a couple days, she swam back to Año Nuevo. And on this trip, the recorder worked. It was able to record sound, including the sound of a boat that caused the seal as she was heading. She was doing for a moment and then swam back deep into the ocean for safety. So it's kind of the same response we see to predators that she saw to a boat. After several more prototyping refinements and lots more pressure testing, earlier this year, we were finally able to deploy an instrument on an adult female. Her number's H391, and she got it in about 2 months. So we programmed the acoustic recorder, which is just an audio moth, potted in a housing with batteries that are potted in epoxy, lithium batteries, and a 1 terabyte memory card. So we thought we had a pressure trigger so that we hoped that the instrument would record for the entire trip. Ultimately, the amount of data that we get is about 700 hours at this sampling rate, so about 30 days. In a very exciting kind of month, she came back to the beach where we were able to head out to Año Nuevo Island, recover her instruments, and download the acoustic data. And she had done a really good job finding food. She had gained even more body mass than is typical for this foraging trip. So she came back very, very fat and did a really good job. I'm very proud of her. And so over the course of her 56-day trip, she swam about 800 miles from her natal beach in California all the way up to Oregon. Most of her dives were around 500 meters, but she did dive down to a maximum depth of about 1,000 meters. And the tag did not crumble under pressure, which is a relief. She hung out offshore of Oregon for most of the trip, several weeks, before heading back to our research site. So most of our recordings were while she was kind of up in Oregon off of Coos Bay up there. And the data that we received contained over 2,000 dives. We have confirmed hearing killer whales, Rizzo's dolphins, Pacific white-sided dolphins, sperm whales. There's also lots of other kinds of noise, ship noise, flow noise, electrical noise, all kinds of other things in there. But there's at least some species that are pretty easy to identify. I don't know if you all can hear this, but any guesses as to who this might be? Not sure. So this is, I'm not sure if we can hear from that full clip, but this is a recording of killer whales and Pacific white-sided dolphins. So really what you hear is the Pacific white-sided dolphins going, they're pretty high frequency, but when the killer whale whistling starts to show up, the dolphins completely stop vocalizing. And at the same time, that seal did that kind of anti-predator behavior and dove back down to the surface. So now we can kind of start to get into our hypotheses and look for evidence of eavesdropping at each of these different scales. So I'll just show you really preliminary results. We haven't done much analysis on this. We're really in the process of doing that. But just the very teaser cutting edge for all of you. So at the scale of the GPS, most of the odontocetes were detected near her foraging location in Oregon. So we looked at her step length, the distance that she traveled over the course of 12 hours, and the more echolocation she heard, the shorter distance she traveled. This is some evidence that the seals are associated with the presence of whales. And, one question we get a lot is couldn't they just be both attracted to the same location instead of being attracted to each other, which is a really great point. And one reason why we're looking at this at so many different scales. So, thank you. So it's important to look at all of these different scales. And I wanted to know whether the seals are changing their vertical behavior immediately after hearing a whale or dolphin. And so here again, we found some evidence that the seal's diving behavior tended to switch to foraging dives when the seal heard echolocation, which suggests that the seals could be hearing odontocetes and then capturing prey and using that information to take advantage of a foraging opportunity by diving to where the prey are located. So the two yellow boxes here highlight times when the animals that are underneath it were present. So in the first one, there was a long bout of Pacific white-sided dolphins, which if you are a whale and dolphin person, you might say, they don't dive very deep. They don't eat, they don't eat mesopelagic fish, but I recently found out that they do. About 60% of their diet is deep water fish, and they can dive to 1,000 meters. So I found that really interesting. And then in the second bout, there was hours and hours of sperm whale detections. And sperm whales and elephant seals don't eat the same prey, but elephant seals and giant squid do eat the same prey. So there's another reason why they should all be gathering at the same location. And then finally, at the finest temporal scale, the strongest evidence for eavesdropping would be that amplitude or volume of whale calls getting louder through time, especially if we can find that in concert with transiting dives as the seals move towards the feeding whales. And so since we're in an acoustic session, you've already seen lots of these today, but just to orient you a little bit, the format of the spectrograms that you'll see is time on the x-axis and frequency on the y-axis, and we can identify different whale species based on the different frequencies at which they call. And the color will be the amplitude or the volume, so the bolder and brighter colors are louder sounds. And this is what we've seen with our seal. So for both dolphins, which are at these higher frequencies, and the sperm whales at the kind of lower frequencies, both of those vocalizations become louder through time. And again, they are happening at the same time that the seal is foraging. So we're really excited about this because it could be the first evidence of eavesdropping between species in the open ocean. And that might be a really cool strategy that not just seals, but other animals in the ocean might use to make their living in this place that's, really quite dark, quite patchy, might be really difficult to find food otherwise.
Cool. So thanks, Allison. Yeah, as you can see, we're really excited about it. We have a lot of work to do. Allison's about to finish up her PhD, so she's going to be hustling to sort of use a bunch of analytical approaches to figure out exactly what the strength of evidence for this eavesdropping is in a really quantitative and rigorous way. We're also planning to deploy 10 more instruments next year and also produce a professional science communication video so that people can see what it's like to be a seal swimming hundreds of meters below the ocean surface. We're really excited to show that these echolocation signals may be important signposts in what we consider to be a relatively featureless open ocean. And as human impacts like increasing ship noise and whaling may impact deep sea communities, we can use these tools to understand how things are changing to be able to better conserve these habitats for the species that call them home. We can also combine this tag with other technologies we're already using, like CTD fluorometer tags to learn more about the oceanography, accelerometers to learn more about exactly how much fish the seals are eating, etc. And all of these things can provide really useful integrated monitoring approaches for understanding ocean ecosystems and figuring out how to conserve them and regulate human disturbance like the shipping traffic that is increasing more and more every day. So hopefully we showed you today that we can harness these naturally migrating animals to collect really useful ecosystem information about man-made sound, and that there's a lot of future possibilities that we'd be really excited to talk about how we might expand this tool and this application to other species. This is, of course, becoming more and more important. So we want to thank everybody, particularly the engineers who kept putting things back together after we broke them, and to the whole acoustics community who's really taken us in and taught us more about this tool so that we could use it. And the last thing I'll say is just we've partnered with a bracelet company to sell bracelets that are associated with tracking data from each of our seals, including H391, so you can actually get her tracking data in the palm of your hand. It's a nice little gift and things like that. So feel free to go to follow.com to buy a bracelet. And with that, we will thank you guys for your time, and we're happy to take any questions.
Oh my gosh. That is, first of all, it's so cool. And also every photo of a seal with a little tag on its head makes me smile and laugh. Because they look so silly. You're getting lots of applause emojis. And then there looked like one question came in a few minutes ago. Where did it go? From Chris, asking how much of the recorder is custom built PCBs and electronics versus how much of it is off the shelf hardware.
Yeah, the recorder itself is just an audio moth, and then there's a 3D printed housing, and some various battery configurations that we have tried. So the most custom part is the housing, but yeah, the acoustic recorder itself is just your regular old $100 audio moth.
Perfect. Love to hear it. And there's, I think, a similar-ish related question from Tom saying that he might have missed it, but what makes this acoustic tag different to something like the D tag from the early 2000s that also has a GPS attached and a longer battery life?
Yeah, D tags are awesome, and we hope to put out some soon. But up until recently, they weren't recording at those high frequencies that are needed to detect echolocation. So most of the acoustic tags that have been put out up until now have recorded the sound of like fin whales, which are making really low frequency sounds, and then a lot of work on weather, wind and rain, and other low frequency stuff. But to our knowledge, this is the first time that we're getting those really high frequency recordings of the open ocean. So that's the biggest difference.
Got it. That is so cool, and I definitely want to be tracking all of them. It's so fun to congratulate her on coming back and being well fed. I love that. So we just hit the hour mark. So we will start wrapping things up. But if you have any other questions for any of our speakers today, feel free to drop them in the chat, or send them to the community email address, and we'll try to get those answers to you. I want to give another thank you to all of our speakers today for their lovely and informative and engaging presentations. It's been a joy to talk about all things acoustics with everybody for the last hour. I'm going to end the recording now, but you're all invited to stick around for our after hours session where we stop the recording and have a more casual conversation about the talks, and anything else that is on your mind, conservation tech related or otherwise. So thank you so much again for coming, and we will see you next month on August 27th.